Hello, we are here for one more lesson of this T-Flex CAM training course, and the topic for today will be the punching. This is a very interesting feature inside T-Flex CAM, and it's the last of the different tool types that we have in 2D, and it's very interesting because it's not so common to find this functionality in CAM software. So speaking of what we have this nice function called punching. I've created, or better saying, I've opened one of the files that are inside the standard installation. And this is a 2D plate. And the idea it is, I will show you two brief examples of the definition we need to make on the paths to create these punching toolpaths. This is very easy, in fact. So simply go to punching. We get this dialog box, which you already know in a very similar look for the previous toolpaths. We need to click in the contour punching. Then we can define the contour by the path or by the hatch. I will hide the hatch. I will open the tool file. I have already a file prepared, and I will choose for this particular one this tool that we can see. It's a round punch, and we have this type of tool. So punch, we can define everything, the section, okay, whatever, and the dimensions. And basically, after everything prepared, just say close. So we have the feed rates as normal, rapid and working feed rates, the L1s, and then specifically for the punch parameters, we can define the sheet thickness. We can define the punch width. Okay, we can define something else, or in terms of, instead of punch width, we can define number of punches. Okay, or the step, whatever. I will leave with the punch width. We can define a type of punched hole, if it is continuous or chest type. The difference on this is this will make a continuous movement along the path, and this will do alternative moves. Let me choose the path. I will use this hole here. So I get this kind of toolpath where this round punch will do continuous hits on the plate. I can do this with a change direction, okay, to change this. I can make a radius correction also to turn this, to consider the radius of my tool. And I will do for now the acceptance, okay. It came inside, which was what I want. And I will do a simulation of my plate, and I will do something like this, very easy. Okay, what else do we have here? So corrections, shifts and bridges I will show you on the second example. And we have also this parameter, the crest height, that is defined in this particular case for 0.1. The crest height is this difference here between successive punches, so it's this small dimension here, so this dimension. I will open a little, and I would say, for example, 1 mil, and I will have much less hits. So as you can see, now it's perfectly visible, the crest height. So if I want to make another toolpath on my side, punching, so contour, I have a path here, so this one. I will open my tool file. I will choose one of the tools defined, which is a square, so this one. Okay, I will leave all of these things around here, and I will define these parameters here, the shifts and bridges. So the shift, it's a kind of a delay in the start or in the end. I will say 50 and I will say 30 in the end, so that we can see clearly that does not start in the first point but 50 after, and it will end 30 before. And I can create a couple of bridges. So for example, two bridges, places where we will not have hits, and define those the width of those bridges, for example 100. So let us calculate and let us do a machine simulation. So if you see clearly, okay, so you see this is a little bigger than on this side, so this is 50, the start, ending with 30, and two bridges, 1 and 2. In these two bridges we will not have any hits. So play, and now that's it. Very basic. So these are the topics to consider for the punching process. So I hope this explanation and these two brief examples are clear enough so that you can start using another toolpath type.